Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, Episode 2 of 24. Does Claude expect max tokens to sample, or something else entirely? Every time you switch model providers, you usually have to rewrite your entire API request payload to match their specific naming conventions. Parameter translation magic is the feature that makes this problem disappear. When you call the completion function in LiteLLM, you only ever write your request using the standard OpenAI parameter format. You do not need to look up the specific dictionary keys for Anthropic, Vertex AI, or Cohere. The library intercepts your OpenAI formatted inputs and automatically translates them into the exact structure the target provider requires. Let us look at a specific scenario. You want to query a Vertex AI Gemini model. You need it to use function calling, and you want the responses to be highly deterministic, so you set the temperature to 0.2. If you were writing a direct integration, Vertex has its own unique, deeply nested way of defining tools and setting model generation configurations. With LiteLLM, you ignore that completely. You build your tools array using standard OpenAI JSON syntax. You pass that array along with your temperature value directly into the completion call. LiteLLM grabs those OpenAI arguments, tears them down, and builds the correct Vertex AI API payload before sending the network request. This automatic mapping is incredibly efficient, but it introduces an edge case. What happens if you pass an OpenAI parameter that the target model simply does not support at all? Perhaps you specify a presence penalty, but the provider lacks a corresponding concept. By default, LiteLLM is strict. It will raise an exception and fail the completion call. This is a deliberate design choice. It prevents you from silently losing configuration that might be critical to your application's behavior. Strict failing is safe, but it can be frustrating if you are dynamically routing user prompts across dozens of different models in production. If you want the call to succeed regardless of minor parameter mismatches, you add a flag called drop params set to true inside your completion call. When you enable this, LiteLLM still translates everything it can map successfully, but if it encounters an OpenAI parameter that the target provider does not recognize, it simply strips that unsupported parameter from the payload and sends the rest of the request. The call succeeds and the unsupported parameter is safely ignored. If you prefer to handle capabilities gracefully in your own code rather than relying on silent drops, there is a built-in introspection tool. You can call a helper function named getSupportedOpenAI params. You provide the model name as the argument, and it returns a list of all the standard OpenAI parameters that successfully map to that specific model. This allows you to check what a model actually supports at runtime before you execute the completion call. Here is the key insight. The true value of parameter translation is that it promotes the OpenAI API specification from a vendor-specific schema into a universal interface language for your entire application stack. Thanks for listening. Happy coding, everyone.